what we have for today is called literal equations. Notice we're still doing with equations. So it's still those equal signs. We're not doing inequalities, just equations. And what we have here is that we don't have just x and numbers, but we actually have a lot of different letters. And remember, a letter is called a variable, which means it represents something. So these are different equations that we have, sometimes in geometry, sometimes in science class, where these are formulas basically to find something. Like for example, number 1, this is the formula to find area for any triangle. So A represents area, B represents base, and H represents height. So each letter represents something. So what we're doing is we're going to be solving for one of these letters, which means we're not going to get an answer like x equals 5 in the end. Instead, we're going to have an expression. So we're going to have still letters in our answer. So a literal equation has more than one variable. So far, we've just been working with one variable, where we had like 2x plus 3 equals 8. So a literal equation is where we have more than one variable. So let's say that we had a y in there. 2x plus 3 equals 8y. This is a literal equation. There's two different variables we could solve. Alright, so when we solve a literal equation, our goal is to isolate a specific variable. Isolate a specific variable. And just a reminder, what does isolate mean? What does isolate mean? Anna?
Get it by itself.
Yeah, get it by itself. Get it alone. Just a reminder, isolate means get it alone. And when it says a specific variable, that means we're going to tell you which variable to solve for. Okay? So we're still doing the same process. Remember, we want to get rid of any addition, subtraction first. So we want to do addition, subtraction first, and then we get rid of multiplication, division. It's just now we're going to have letters in our answer. So let's go and take a look at number 1. It says to solve for the underlying variable. And here my underlying variable is h, so that's what we're going to try to get by itself. So I need to get rid of my 1/2 and get rid of my b. Alright, so if we take a look at this, let me zoom out a little bit for you guys. So I need to get h completely alone, so I need to get rid of everything else with it. Alright, so I have 1/2 times b times h. So if I am currently multiplying, what's the opposite of multiplying? Dividing. So in order to get rid of my multiplication, I want to divide to get rid of it. Now, we talked about how sometimes it's easier instead of dividing by a fraction, right? I can say divide by 1/2. That looks a little messy on my calculator. You can do it that way. But something we can do instead is multiply by the reciprocal, so we can flip it upside down. So again, reciprocal means we flip it upside down, but we multiply by that. Okay. So again, you can either divide both sides by 1/2, or let's go ahead and say multiply by 2/1. So I'm going to multiply by 2/1. By 2/1. Whoops, not 2/2, 2/1. Right, so this will get rid of my 1/2. If you put in your calculator 1/2 times 2/1, it just gives you 1. So those will go away. 2/1, what's 2 divided by 1? 2. Just 2. So what we have here is really just 2a. We got rid of our 1/2, so we have b times h. Alright, so again, I want to get rid of my b. I have b times h. What's the opposite of multiplying? Divide, good. So I divide both sides by b. Alright, so I have h. And I can't simplify anything over here. This is just 2a divided by b. And that's our answer. And that's what our answers will look like, where we still have those variables because we don't know what those numbers are going to be. So what we've just done here is what we have found for any triangle, we have an equation for the height. So if I wanted to find the height of my triangle, I would do 2 times the area divided by the base. So this is helpful for us when we get to other classes, like next year in geometry, they'll deal with the area of a triangle, and sometimes you have to solve for your height instead. There's also things like number 5 is distance equals rate times time. You've dealt with that actually before in your science classes. It's again something that you'll do in the future. And so maybe we don't have distance, or maybe we aren't trying to solve for distance, we're trying to solve for rate. So this will allow you to do that. All right, let's go take a look at number 2. All right, so it says we want to get the W by itself. Now, when we see this 2 in the parentheses, what do we have to do with that? Distribute. So let's go ahead and distribute that. So P equals 2 times L. I'm going to write it in cursive. It's a little bit easier for me. I don't want you guys to think I'm writing a 1. So 2 times L plus 2 times W. You should know when to go. All right, so we need to get W by itself. We have a positive 2L. How do I get rid of a positive 2L? Then subtract 2L from both sides. Can I combine P and L? No, they're two different things, so I can't combine them together. So I just have P minus 2L. Those cancel, and it's going to be 2W over here.
How do you know which one you're supposed to subtract?
What do you mean?
Which variable to subtract?
So we're trying to get W by itself, so I'm just leaving the W
The underlying
alone.
one is the one that we're trying to get, right?
What's that?
The underlying variable.
Yeah, it says solve for the underlying variable, so that's what we're going to leave alone. All right, and now we have 2 times W. What's the opposite of multiplying? Dividing.
So it's going to be P
Minus 2L over 2. And that crazy looking thing is our answer. So the literal equations are actually a little bit easier in that we can't combine anything, right? P minus 2L, I can't combine that. So it just stays as a kind of crazy looking answer. A lot of times you will have fractions in your answer. So what number 2 is telling us is that perimeter, and this is specifically for a rectangle or a square. Our perimeter is 2 times the quantity of length plus width. So what we found here is an equation for the width. So these variables do represent something. We're just dealing with it in terms of all the variables. All right, so this is volume equals length times width times height. And this is actually the equation for the volume of any type of cube or rectangular prism. Like, for example, if I wanted to find the volume of this, what does volume mean? Does anyone know what volume means?
How much you can hold inside.
Right, how much you can hold inside. So if I were to like pour water into it or pour sand into it, how much could it hold? And so this is actually the equation to find volume of like this tissue box here. Again, you don't have to know what it means. I'm just letting you know that these are actual things. I'm not just like throwing letters at you just for the fun of it. These do actually represent something. So here they have length times width times height. We want to solve for our length. Now again, I have times W and times H. What's the opposite of multiplying? Dividing. We're going to be dividing both the W and the H because they're both multiplying. So I have volume divided by width times height equals, my W's cancel, my H's cancel. That was a one and done. Okay, questions on our first 3. It's really the process that we're going to go through. It's just the same thing as before. It's just we have letters instead of numbers. What's that?
For like number 5,
Yeah.
number 4, when number 4 is trying to find both variables, how would you solve that?
So it's supposed to be just R's underlines. Only R is underlined, not T. It's just in the font R is bigger than the T is, so that's why it's longer for the R and smaller for the T. Yeah. Otherwise we'd be done, right? There'd be nothing to get rid of. So number 4, we're trying to get R by itself. This is distance equals rate times time. So for example, if you're driving in the car at 55 miles per hour, that is your rate. and let's say you're driving for 30 minutes, that would be your time. You can multiply those together to find out your distance that you've gone. So that's what that equation is. And so we want to get r by itself, so we're going to leave r alone. I have r times t, what's the opposite of multiplying? Dividing, so I'm going to divide by t on both sides. And then distance divided by time equals.
It's gonna be the same for the number 5. But this time
same
it's
idea.
gonna be like d divided r equal to.
That's right. Yeah, so 5 is very similar, except we're trying to get t by itself. And so I want to divide by r, because we're multiplying once again. So d divided by r equals. All right, number 6. This is A equals L times W. This is area equals length times width. And this is actually true for any parallelogram as well, or actually, sorry, not parallelogram, for any rectangle as well as square. So this would give us the area. So we are trying to get W by itself. So I'm trying to solve for the width. I have L times W, what's the opposite of multiplying? Dividing. So I have A over L equals W. That's right. So there's not really a whole lot we do with these problems here, right? We just divide or add, subtract, or multiply to get rid of our letters. Wait, real quick, before we continue, who can explain to me the difference between area and perimeter? Eric?
The area.
Area is only.
Like, let me draw a picture so you can refer to it. Let's suppose that this is a fenced area. Maybe there's some cows in here. You guys have seen cows before, right? Okay. They have ears.
I know the perimeter is the whole, like the whole outside.
The area is the whole inside. Right?
So let's say this is my fenced area. So what would the perimeter be? What are you doing when you say the whole outside?
Calculating how long or how wide the sides. Let's say the fence.
Yeah. Yeah, how long the fence would be. So I'd have, let's say it's 10 feet. 10 feet plus 9 feet plus 10 feet plus 9 feet. We're adding together to find how long that is. Basically, if I were to measure only the outside. Good.
Right, to find the area, you would do just length times width.
Good. So our area is telling us how much is inside. Like if I were to measure all of this inside, like how much grass do the cows have to eat? You would multiply our length times width. So 9 times 10 would be 90 feet squared. Okay. So perimeter is just telling us the length of the outside. We add those together. So we would have 10 plus 9 plus 10 plus 9. But when we want area, like how much grass there inside, that's what we multiply 10 times. Okay. In a couple of classes, we're going to be doing more with that, so I just want to make sure we are aware of the differences there. Any questions on the difference between area and perimeter? Volume is once we get to like, this is just a 2D shape, right? It's a flat surface. Volume is when we have a 3D shape, like the tissue box. Okay, so in literal equations, one of the more common things we do is the bottom half of our notes here. So one of the more common things is to solve for y. So you'll notice in each of these equations, we have an x and we have a y. Okay? So it says to rewrite the equation so that y is a function of x. Now I want you to go ahead and put a circle around this here. Y is a function of x. That's a fancy way of saying y equals. Remember back to our very first day this year, we said that is means equals. So y is, y equals. And when it says a function of x, what that means is you're going to have x's over here. So we have y equals. We're trying to get y by itself. Now this is still a literal equation because there are two variables. But you'll notice we have also some numbers in here. So we're going to do the same thing as we did above. Get y by itself. We just might actually have to simplify a little bit, actually combine like terms. Now the reason why we're doing this is because next unit, we're going to talk about graphing a line. Does anyone remember graphing lines from last year? So when we graph lines, we have both x's and y's, and so this is kind of preparing us for that. Okay. So number 7, again, we want to get y by itself. Highlight that. Okay. So I have a positive 2x. What's the opposite of positive 2x? Minus 2x. I'm going to move the whole thing over just like we would before. I'm left with y. It's a positive y, so I don't have to write the positive. Equals. And so we could write 5 minus 2x, and that would be perfectly fine if you wrote that on your quiz or your test. But I'm going to go ahead and let you know that in preparation for next unit, we're going to write it where we have our x first. So we have negative 2x, and then this is a positive 5. So for right now, either of these would be acceptable. Next unit, we're going to be doing this, which is why I'm going to have us practice that now, because this is what we call slope-intercept form. From this, I can, on my graph, I can know that this is going to be a line that starts here at positive 5, so 1, 2, 3, 4, 5, will go right here, and has a negative slope of negative 2. So it would look something like this. That's what we're going to be doing next unit in the unit after. Yeah, y equals mx plus b. So this is what we're going to be doing. We're not doing that right now, so don't worry, we're not graphing lines yet. But we're going to need it in this format. Y equals mx plus b. This tells me my y-intercept. This tells me my slope. And so I'm going to have us practice in that format now, so when we get to it, that's not so difficult. We can focus on the graph. But again, that's what's to come. I don't want you guys to think that we're just making up math. It's real. There's a reason why we do it. But that's why what we're doing now is to help. Okay. So number 7 was pretty basic. Let's take a look at number 8.
My pencil flew
Where did it go?
on your chair.
On my chair? Well,
Yeah.
here, you should have just asked me for it. Rodrigo, you're so nice. Okay, so again, for number 8, we want to get y equals. Now, first, we need to get rid of any adding or subtracting first. What's the opposite of negative 7? Good, positive 7. Do this on both sides. I still have y divided by 5. That didn't go away. Then I have negative 2x plus 7. Can I combine those? Why can't I combine those?
They're not the same variable.
Right, they're not the same variable. One has an x, one doesn't. I have negative 2, I don't know, dollars. You can have negative amount of food. And I have 7 cookies. I can't combine those together. Okay, I do need to get rid of this 5 though. It's y divided by 5. What's the opposite of dividing? Multiplying. So I'm going to multiply by 5. Now here's where we want to be careful. Notice I'm putting parentheses around it because I'm multiplying the entire side by 5. Everything by 5. So we do have to distribute it. So I'm multiplying everything by 5. Over here my 5's cancel, which is perfect. That's what we were hoping to do. But as Eric said, we are going to have to distribute. My negative 2x gets multiplied by 5. That gives me negative 10x. And I have to take my positive 7 and multiply by 5. What is positive 7 and 5? 35. Plus 35. Good. And that's your answer there. Make sure y is by itself before you decide that's your answer.
We have to distribute it.
We did have to distribute it. Because we're multiplying, so I have to multiply the entire side, not just a part of it, but everything by 2. Alright, let's take a look at number 9. Okay, so I have 9 minus y equals 1.5x. It's a positive 9. The negative goes with the y, so it's a positive 9. What's the opposite of positive 9? Minus 9. Notice I still have my negative there, so I've got to write that in front. Negative y. I can't get rid of that just yet. And I'm going to write my 1.5x first. And minus 9. Now, if you were to stop right here, put a box around saying done, you wouldn't be completely done yet. What do we have to get rid of still?
The negative.
The negative. The y has to be completely alone. How do I get rid of, this is the same thing as saying negative 1y.
So you just divide by 1.
Yeah. We're going to divide by negative 1. You could also multiply by negative 1. I like to think of it as negative 1 times y, the opposite of multiplying is dividing. Okay, so I have then y equals, and again, we have to be careful. Just like over here, everything was multiplied by 5. Over here, everything is divided by negative 1. So we have to do that I-heart division. What's 1.5 divided by negative 1? Say again? It's going to be a negative 1.5. So 1.5 divided by negative 1, if you put that in calculator, gives you negative 1.5 x. I don't know why I changed the variable, it's an x.
You have to multiply with the negative 9 also.
Yeah, so we're dividing negative 9 times divided by negative 1, and what does that give us?
The positive 9.
Positive. So again, if you're multiplying by something on both sides, you have to multiply everything by that. If you're dividing both sides, then you have to divide everything by that. So we have questions on 7, 8, or 9. Okay. So we'll just do a few more here, and then I'll have you do some practice. Alright, 10 is not so bad. Again, we have to get y by itself. Now I have negative 3y plus 10. I want to get rid of my 10 first. Opposite of adding 10 would be subtracting 10 to get it. 2x minus 10. So notice it's still a negative 3y. Alright, and we have negative 3 times y, the opposite of multiplying. To divide. And once again, I have to divide everything by negative 3. When you so I have 2x divided by negative 3. In your calculator, when you put 2 divided by negative 3, what do you get?
When we do what?
2 divided by negative 3. It's 0.6 repeating, right? Put that back into fraction. What does it say? Negative, sorry.
2/3.
Good. So it's that negative 2/3. It didn't simplify at all. And I still have the x. I have to take the over x. Now in your calculator, do negative 10 divided by negative 3. Next thing. Negative 10 divided by negative 3. What is that? 3 1/3. Now, we can keep it as the improper fraction, where we have the bigger number on top, so that'd be positive 10 over 3. Notice, though, it's positive, and negative divided by negative is positive. All right, good. And over here, we have y. Now, again, this answer is okay, but when we write it, we always put the y on the left side. So I'm just going to flip it around. Negative 2/3 x plus 10/3.
Wait, so we wouldn't write the answer that we got for 10 divided by negative 10 divided by 3.
If you can put 3 1/3, that would be fine. Like, you can have it like this.
Or could we just leave it out like this, like this?
You don't want to leave it here because we still have to divide that out. Again, when we go to graph, you would have to know that it's negative 2/3 and 10/3. Like, this is my y-intercept, this is my slope.
So either answer would be fine, so 10 divided by 3 or...
Yeah, it'd be fine to leave it as 10 divided by 3. If you want to put 3 1/3, that's perfectly fine as well. It's probably more common you'll see like this, but either way, like, I would accept either one. It's the same number. All right, any questions with 10? All right, let's go to number 11. Once again, we've got that distributed we have to deal with first. So let's go ahead and distribute. So I have 1/3 times y. Good. 1/3 times positive 2. What does that give us?
Negative.
Positive 1/3 of positive 2. Well, hopefully it's a positive. What's 1/3 times 2? Use your calculator if you need to. 2/3. And then I still have plus 3x equals 7x. Okay? We want to get y by itself. So we've got a couple of things we need to get rid of. Let's go ahead and subtract our 3x. We can combine that. So I have 1/3 of y. I want to make sure my y doesn't sneak down to the bottom there. Put it next to it. Plus 2/3. What is 7x minus 3x?
4x.
4x. Good. Okay. Still need to get rid of addition, subtraction. So we have to get rid of our plus 2/3 with the opposite of adding. Subtracting. Can I combine 4x minus 2/3? Nope. They're different letters, different variables. One has a letter, the other one doesn't. So I still have 1/3 y. And then I have 4x minus 2. Okay, now comes, it's not necessarily tricky, it's just probably the weirdest part of what we've done so far. So again, I have 1/3 times y. Now we talked about the opposite of multiplying is to divide by 1/3. But look at how crazy this looks if I put it as divide by 1/3. That's going to be pretty crazy to look at in your calculator, so let's just go ahead and do our easier way. And this really works only when we're dealing with fractions. Alright, so I have that fraction of 1/3. To get rid of that fraction, the easiest thing is to multiply by the opposite, or the reciprocal. We flip it upside down. Now again, if I do that on the left side, I have to do that to everything on the right side. So put a big old set of parentheses around it. And we have 3 over 1. Now, what is 3 divided by 1? It's just 3, right? So this is the same thing as just saying we're multiplying by 3. And that's the same thing. Now, if in your calculator you type it as parentheses 3 over 1, that's okay. It'll give me the same answer. That's all that we're saying. So 3 times 1/3 gives me just 1y. And we're going to have to distribute here. What is 3 times 4x? It's 3 times 4.
12.
12. Very good, Andrew. Andrew's the mental math over here. Alright, and then 3 times negative 2/3. And it's good if you need to use your calculator for this. Go to put it in. What's 3 times negative 2/3? Make sure you put parentheses around your fraction if you don't know the alpha fraction. I got 1 negative 2. Does anyone else get the same thing? Got 2 more. Good.
So you just end up distributing, right? After
Yeah, we have to distribute again. Just like that other problem we had. And then turns good. Alright, one more before I have you practice them on your own. Do we have any questions on 10 or 11? Where'd you number 12? Alright, number 12. So if 3x plus 5y equals 7. Again, I need to get y by itself. It's a positive 3x. Right, there's no sign in front. That means it's positive. What's the opposite of our positive 3x?
Oh,
Minus 3x. So it's a positive 5y. So 5y. And you could write it as 7 minus 3x. That would be fun. We'll flip it around in the end. Can't combine them, right? One has a letter, one doesn't. And then once again, 5 times y, the opposite of multiplying. Divide. So over here, I have y. And once again, we're gonna have to divide everything out. So I part division, 7 divided by 5. What does it say? 1.4. You could also leave it as a fraction if you hit math frac. What does it say? Is it still in your calculator?
750.
Yeah. So you can either write 7/5 or 1.4. Because it just says 1.4 doesn't keep on going and going and going, that's okay for you to write. So I'm going to write it in 2 different spots. So he has 2 twos. So 7/5 or 1.4. Okay? And then we have -3 divided by 5. What does that give us?
0.6, negative 0.6.
Good. Minus 0.6x. And again, if we do math frac, what does it turn into? Yes, but it gives us something simplified. You're correct, it is -6/10. That's why. Good, 3/5. So oops, I combined my decimals with the fractions. Oops, let me try it. 0.6x or 3/5. So again, either one of these would be fine because the decimal ended. So we have an ending point. If it kept going on and on and on and on, you want to leave it as a fraction because otherwise you'd be rounding. But for our final thing, remember we want to have our x first. So I'm just going to go ahead and rewrite this. Y equals -0.6x. And that's a positive 1.4. Just make sure you keep your signs with it. Or again, you could write it with a fraction. Y equals -3/5 x. And it's a positive 7/5.
If we ever get a big fraction, are we able to simplify it?
Yeah, some fractions, so always check on your calculator see if you can simplify it. Like, for example, if I had, let's just say, 48 divided by 24, that can be simplified, but if I had 49 divided by 24, that would not be simplified. So just check on your calculator, see, put it in and see when you hit math frac what it gives you. It'll simplify it for you. Okay. So again, let's go ahead and just recap real quick. We have kind of 2 different types of literal equations. The top half is when it was just mainly letters. And again, we have to distribute, but then we're going to get rid of any adding or subtracting first. If we did here, remember to get rid of adding subtracting first, and then get rid of multiplying and dividing. Same idea when it says rewrite the equation so that y is a function of x. Y is y equals. We want y equals. And again, get rid of any adding or subtracting first. So if it didn't all these, and then get rid of your dividing there. Make sure you have it in this form. Y equals our x. Questions with this before I have you paired with someone to work on practice? All right, so let me go ahead. Actually, I'll pass out the practice first. Here you go. Okay, I'm going to pass it first. Get everyone paired up, and then we'll take a look at it.
It says to be right at 9:45. To ask the class connection down or SCA.
Let me first talk about this and then I'll take a look at that. All right, guys, so everyone should have the literal equations practice. Is there anyone that did not get one? All right, so you'll notice on the front side, they actually tell you what these represent. Area of a kite, that's something we do in geometry. Circumference of a circle. Now, for number 5, real quick, I feel like it's written kind of funny.
2 times pi.
Yeah, this is 2 times pi times r. It's not like a double I. So this is pi. It's a Greek letter. It represents 3.141579 yada 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 yada. So treat this just like any other letter, okay? But I want you to know it's not I. It's a single thing called pi.
Would we be able to write out as 3.14, or do you want us to keep it in the?
I want you to leave it in this because 3.14 is just a rounded number of it. It's an approximation. This represents the whole big long decimal. Great. So on the front side, they actually told you what those represent. Again, you don't have to know what they represent, but it's nice to know what it is you're doing. And then here, notice it says rewrite the equation so that y is a function of x. Y is, y equals. Now on the back side, I want to take a look at this. You'll notice 19, 20, and 21. The reason why we've included these is these are questions that are like the SOL questions. So they've given us the formula, and then it tells you Raul wants to find J. So J is what we're trying to get by itself, and then it has multiple choice answers. Same thing here. It says which shows this formula itself for G sub 1. G sub 1 is what we're trying to get, and these are your possible answers. Now notice G sub 1, G sub 2. Those are 2 different things. If I'm remembering correctly, so this is talking about our average. So these are represented by 2 different numbers. I think there's another one that's like this. Let me see real quick.
You wouldn't be able to combine them together because they're not the same.
Correct. Like if you look on the front side, D sub 1, D sub 2, that represents the distance of 2 different diagonals. They're 2 different things, which is why they have the little 1 and the little 2. So even though they both say D, they're not the same thing, so you can't combine them together. So I just want to make sure you're aware of that. Okay, is there anything to knock with the practice? All right, let me go ahead and pair you guys up, and then I'll have you move to work with one another. How many people do we have?